a hell of a speaker today. I'm Damien Montero. If you don't know me, I'm one of the organizers here. I'm the organizer. Florida.js always has some of the best speakers, and then sometimes me. So today we have the amazing Val here has been asked me to, do we call him Val? And all that. We learned about that a little bit earlier. We at Florida.js, we have JS in their name, but we want to do about anything, AI, JS, anything to do with web, anything with what controls our world. I think we want to hear about it. If you want to present on it, let me know, or else, oh my God, I just got to get the best presenters and all that. But if you want to present instead, love it and all that. So you don't have to be Val's level of things, but I thought you were going to present something else, and this is better. I think we're going to present your amazing new next project. So maybe you should talk about that at the end.
Oh, I'll mention that a little bit. But I wanted to focus on something that's like a little bit more educational as opposed to just
this is amazing. This is perfect and awesome, but you are an amazing individual. But I'll let you do the intro. Thank everybody. So here we go, Val.
Oh, thanks, Damien. I really appreciate it. Can everyone hear me okay? Yeah. Great. So, hi everyone, my name is Val, and I'm going to be talking about practical AI chat today, doing it in Node.js and Vue. And I do, and I'm the maintainer of Mongoose, which is the most popular MongoDB ODM for Node.js. Gets about 3 million downloads a week. I've been maintaining that for about almost 12 years now. And I mostly do freelance AI web development down in Miami. One thing that's kind of different is, again, I use Node.js primarily for AI dev. I don't do much Python or anything like that, so I'm going to be focusing on showing how I work with or how I implement AI chat with Node.js and Vue. So first, a brief aside on why I like chat UIs. And oftentimes when I talk to people about like why I'm so excited about chat UIs, they picture in their head just some spammy chat bot or customer support bot that you just keep telling them, send me to a person, and it says, are you sure? I'm a chat bot, I can help you. And you say, no, send me to a real person. It's not just that. One of the things that I think that chat UIs are really going to change about the way we think about UI design is, I think, kind of the deeply nested menus are going to slowly but surely get replaced by prompt-based inputs. So how many of you have had to search for just something that you can find in a menu? Like go on Google and it tells you, hey, look at this menu, that menu, and you click in and you find the thing. Whoa. So why not just tell the program what you want it to do and have it do what you want it to do? For example, earlier, probably 2 days ago, I just somehow hit a couple of keys and accidentally turned off line numbers in my code editor.
Oh my!
Like how do I? Oh boy, this is a crisis. How am I going to fix that? So I would have loved to have had a prompt input where I could just say, turn back my line numbers, please. But no, I had to go to Google. I had to scroll through a GitHub issues thread. About 10 or 15 messages in, I finally find, oh, you have to click Shift Control E with a space. I don't know, something weird. So yeah, chat UIs I think are going to make our user experience a lot different. Things are going to look a lot more, we're going to have a lot fewer menus, we're going to have a lot more text inputs. I think that will make user experience a lot better. So again, why this talk? Building a chat UI gets more complicated than just calling the OpenAI API, right? I mean, everyone has seen like, oh, here you have this app that's just a ChatGPT wrapper. All it does is just call the OpenAI API. That's great, but things get a little bit more complicated the more sophisticated your application gets. You start thinking about storing messages in threads. You end up having to store your messages. You end up having to summarize older messages or the entire conversation to provide an overview of what's being talked about. Token management is another one. You don't want to go over too far, or you don't want to go over your context window limit. And if you throw too many tokens at OpenAI, you get slow, or your response gets slower, and you end up paying more naturally. And the trickiest part, at least in my experience so far, has been streaming. So streaming the response from OpenAI. Instead of just sending all of your text to OpenAI and waiting for the entire response, you instead send your request and get the tokens back as as OpenAI generates them. So tech stack that that I'm working with, Node and Express, MongoDB and Mongoose. As you might imagine, I'm a little biased on that choice. The OpenAI API, I end up using ChatGPT and the OpenAI API for just about everything. Not to say that Claude isn't great, but I just started using the OpenAI API and it does what I need it to do. Vue on the front end, and then I use a library called TickToken for accounting tokens, which I'll talk more about later. So quick little demo of what of the sample app that this talk is based on. It's called JS Ahoy. It helps you write JavaScript like a pirate. So it's a quick little demo. Hopefully this one works. So let me just go in here and, well, what's a decent thing to ask for a JavaScript programming bot that writes code like a pirate? Anybody have any ideas, or I'll just throw one at it? Okay, how to import Vue from a CDN. So now you see it's starting to stream the response from OpenAI, and it's talking like a pirate. And it's coding like a pirate too. Your script where you initialize Vue and message ahoy world. I think that means it's following the instructions to write code like a pirate. So, and then you have little things like, okay, the messages are all organized into threads. So like I tested this one before, which was, okay, hey, reverse an array. So, hey, do you want to be reversing an array? Okay, use recursion instead. And yeah, we get some fun little pirate generated code. And again, there's thread summaries, so thread titles automatically generated from the content. All sorts of fun, neat things for this talk to cover. So that's the general idea of what I'm going to be building or showing you how to build in this talk. So the full source code is on GitHub. You can pull it up either from the link or from the QR code. Learned that from my last talk. QR codes are great in talks.
The problem is it doesn't work on laptops.
Oh yeah, that's right. Okay, so yeah, full source code available on GitHub. Great. So first things first, talk about building basic ChatGPT wrappers. Well, here's a basic ChatGPT API wrapper. One simple blocking HTTP request. You make a post to the /chat endpoint with an array of messages in the body. Make an API request to the OpenAI API with your OpenAI key, and print out the response. Great. So that's your example of a very basic ChatGPT wrapper app that people on the internet love to hate on. However, this is the very basics of how you make a request to OpenAI. We'll add some streaming later. But the first thing to notice with this request is messages. So it's not one message, it's multiple messages. When you send a request to the OpenAI API, you send the entire chat history. So you need to remember every message in the chat, and then you also need to cut off older messages if there's too many. So you send the full history every time, and the array of messages looks something like this, where you have an array of objects, property role and property content. So role is whether it's the person, whether it's the AI assistant, or whether it's some system-specific instructions. And then the content is, well, the content of the message. So how we store this in MongoDB with Mongoose schemas, you have a thread schema. A thread just has a title, And then messages are scoped to threads. So you have one-to-many relationship between threads and messages. Chat messages have a chat thread ID that points up to their parent thread, then roles, or a role property, and content, that's a string. Different message roles for the OpenAI API, and there might be other roles if I remember, but I don't remember off the top of my head, but these are the 3 roles that I use. So user is the person making a request to the API. Assistant, the assistant role means the message came from OpenAI, and then system is your app instructing ChatGPT what to do. So it's providing rules, instructions, guidelines, set the tone. These are the things you can and cannot do, so on and so forth. So first off, you need to be able to create a chat thread. Here's an API endpoint that creates a chat thread by calling chatThread.create in Mongoose with the provided title. Title is optional for chat threads because it can always be inferred later from summarizing the conversation. Creating a message is kind of fun because when you try to create a message, you actually end up creating 2 messages. First, there's the user message with role user. That's the message that's coming in from the user. So this API endpoint, first you look up existing messages by the chat thread ID, and then you add a new message with role user with the user's content, and you save that new message. But then you also send all of the existing messages to the ChatGPT or to the OpenAI API. And then when you get the response back, then you save the OpenAI API's response as a new message with role assistant. So, yes? Oh. That'll be in either the next slide or the next slide. Yes. Sorry, code? Which code? Oh, the role. The role or the chat, the thread ID. Yeah, there's you store the. That's a good point actually. So yeah, right up here, when you create the user's message, you set the chat thread ID, which associates that message with the parent thread, and then similarly, when you get the response from OpenAI, you also set a chat thread ID on that message. So all the 2 messages that are created in this endpoint are associated with the same thread. Yeah. Okay, so there's that. Anything else interesting to discuss here? Oh yeah. So again, this entire response or this entire endpoint is blocking in the sense that you don't get partial responses back from OpenAI yet. Now, one important thing to note is the system prompt. The system prompt or the message with role system or a message with role system is used to define kind of like the tone, the rules of what you want the OpenAI API to do with this stream of messages. You usually put the system prompt as the first entry in the messages array, and it really changes pretty much everything about future interactions with this API. So for JS Ahoy, the system prompt is just very simple. You're a developer that writes JavaScript in Pirate Voice. Again, if you want to build something more legitimate, first place to start is the system prompt. I'll talk a little bit more about the system prompt, but the general idea is that in LLM messages here, the system prompt will be the first one thing. So I think I have. Yeah. Well, I have a little bit of an example here. So yeah, move next topic. AI is great at summarizing things. So you give it a bunch of text or a bunch of messages, it can do a very good job of just synthesizing what was talked about into a few words. Even very basic models are very good at this. So what I do here is if the chat thread doesn't have a title, we create a new system prompt that's specific to the task of summarizing. So the system prompt is, instead of talking like a pirate, it's just summarize the following conversation in a short sentence, 3 to 8 words. And then call get chat completion, which is a function that just calls the OpenAI API. The one interesting detail here is that I'm using a different model here. I'll talk a little bit more about different models first. But yeah, bottom line, AI is great at summarizing content. So if you give it a bunch of messages, so in particular, what this will do is the first time that the user tries to create a message, we'll go and ask ChatGPT to summarize the user's first message into something short and just use that as the chat title. So you'll see over here, I didn't write out the actual title. That title was just inferred from my message here. So again, switching between models is something that people talk a lot about. I don't worry as much about it just because most models do a pretty good job by themselves. I haven't really, but for cases like summarization, it's great to just do a model that's fast and cheap because you don't need a model that's smart. So oftentimes switching models is about just using a cheaper model that gets you faster results as opposed to a more sophisticated model that gives you maybe better results for more complex tasks, but is overkill for something simple like summarizing a short conversation. So ChatGPT 4.0 is the default that I'm using for JS Ahoy. But for summarizing, 4.1 Nano is the super fast, super cheap model. There's also other models that have access to various other OpenAI features. The one that's most interesting right now is web search. There's certain OpenAI models that actually search the web for you and pull in information for retrieval augmented generation. But that's a topic for a whole separate talk. So okay, so far this actually mostly works. So you have a post chat endpoint where you create a new thread and get the ID. The client is responsible for remembering the chat thread ID. And then you have an endpoint to store a new message from the user, send all of the existing messages to the OpenAI API, and then store OpenAI API's response as an assistant message associated with your chat thread. So you can build a client on top of this, and it will work. It'll just look a little slow because you'll have to wait for the entire OpenAI API response to come back. You won't get the nice typing effect that I demonstrated before. I'll talk about that one more later. But first, I wanted to talk. Well, there's a couple of other endpoints we need to build in order to be able to build a reasonable client on top of this API, though. Getting a list of existing chat threads, also pretty important because, well, this little threads sidebar on the left, you need to get the chat threads from somewhere. And then you also need to be able to get the messages for an existing thread. Like clicking on a different thread, you get all of the messages from that thread. So here I clicked on this other test I did for creating a Tailwind config. But another thing I wanted to talk about before we get to the streaming side of things is tokens. So you can't send arbitrarily long text to the OpenAI API. For practical purposes, you can send a lot of text, but you can't send all the text in the world. And the amount of So yeah, the amount of text that you can send at once is limited by a concept called tokens. Different models have caps at a different number of tokens, and the tricky part is that tokens are not characters or words. So here's an example that Microsoft often uses to demonstrate that tokens are usually one word, but sometimes things like don't are actually two separate tokens. Indivisible is two. There's other things like Unicode characters are usually one token each. Sequences is for some reason two tokens. So bottom line, it's pretty difficult to determine like how many tokens are in a given string. And the most infuriating part about it is different models have different determine tokens differently. They tokenize text differently. So even different OpenAI models can have different amounts of tokens for the same text. And then, if you're talking about like a Claude API or something different, you'll get completely different results. Same thing with Llama as well. The amount of text that you can send at once is often referred to as the context window. You might have heard that term before. Tick token is a nice little NPM package that handles counting tokens for various different common models. So, for example, you can just import tick token. You can get the encoding for a particular model, like GPT-4o, let's say. Once you have the encoding, you can encode a given text string and get the amount of tokens in that particular text. You also need to add 4 because that's OpenAI specific number. OpenAI says that the number of tokens for a given message is approximately just the token length of the message plus 4, because 4 is how they encode things like the role and other information associated with the message. I don't understand the exact particulars, but that's what Google assures me. So again, most modern OpenAI models have pretty huge context windows. So ChatGPT-4o is limited to 128,000 tokens per message. So rather, you can send 128,000 tokens worth of messages in your API request. So when you say messages, that can be up to 128,000 tokens total. GPT-4o Nano actually has a bigger context window, paradoxically, than GPT-4o, which is a little strange, but that's how it works. And yeah, the comparison that I always make is, the entirety of War and Peace is about 800,000 tokens. So you could send the entirety of War and Peace to GPT-4o and still have room left over for some questions. The easiest approach for making sure that you don't run over on tokens, because, well, it is possible users will try to abuse your software, right? The easiest approach is just cut off old messages. Add the newest messages one at a time, or add messages one at a time in order of most recent first, until you run out of space in your context window, and then drop all the old messages. Smarter applications like if memory serves, the actual ChatGPT web UI will actually go and summarize your old messages and store them and pass those in. So if you have a very, very long message thread that it goes well over the context window limit, ChatGPT will actually summarize the information from the older messages in the conversation and pass those in as well. But the easiest approach is just cut off old messages. And sometimes you may also want to cut off before you get to the context window limit, just because the more messages you send, the longer ChatGPT has to respond, or the longer it takes to respond. Because again, ChatGPT needs to process every input token that comes in. Like the fundamental idea of how an LLM works is it's a function of, given all of these tokens before, what is the most likely token afterwards. So it needs to go through all the tokens you pass in and then determine, okay, here's the next token. And then it needs to go in and take all of your input tokens plus the first token it generates to generate the second token. So the more input tokens you pass in, the slower your response is going to be. So yeah, trimming, so long story short, trimming messages. Little trim messages to fit function. Given an array of messages, get an encoding for the model, loop over each message in order, most recent messages first. When we get to max tokens, we break. Otherwise, we just add the message to the array and return the trimmed array of messages. So the hard part, or the most fun part that I've been talking about is the streaming responses. So the OpenAI API actually supports returning tokens as they come in. As it generates new tokens, you get more tokens. So there's two things. So what you end up getting back from the OpenAI API is not one response. You end up getting a bunch of responses that look kind of what you see on the right. You have like an ID, a bunch of junk, but most notably there's choices with a delta.content property. That's the actual content of the response. Yeah, one of these per token. So yeah, it could be a lot of data sent over the wire, but on the other hand, it's nice because you get the response to the user faster. Again, what you end up doing is with Axios, what you need to do is set response type stream that tells Axios to return a Node.js stream, and then you need to also pass in stream true to the OpenAI API in the request body. And then, of course, pass in your system prompt and the trimmed messages array, trimmed to whatever the cap you set for your context window is. And then you'll get back a stream. Now, this code kind of gets a little bit hairy, but the general idea here, you get a bunch of, each time the stream generates a chunk of data, the chunk of data has some lines that may or has an array of lines. Those lines start with data colon, and what comes after data colon is a JSON string containing all of this stuff. So what we end up doing here is parse the data. Just look at the try-catch block down here. Parse the data, take out the content, and add the content to our existing array, and then also send it to the front end using res.write. Send SSC is just going to be res.write. And then finally, at the very end, the OpenAI API sends just square brackets done, or data colon square brackets done to indicate that you're done. There you end up sending a server sent event as well. Let me see if I can. Yeah, I would really love to drill in this code today. No, I do not, unfortunately. That would have been a great idea. See, you're smart. I should have done that. Yeah, so general idea here. This is a response from the OpenAI API. We're going to stream this, parse and stream the response to the client. Yeah, something like that. So here we're going to look at the Vue UI as well. So basic scaffolding out for the front end side. I'm going to be building a simple index.html file. The idea here is you have importing Vue from CDN. So taking a CDN, pulling in Vue. You have an app div right here that has, and then you create a Vue app that's mounted on that div. The easy part, or relatively easy part, is the things like thread layout. So fetching a list of threads. Basically, you have just threads, and then you have a Vue UI that loops over the threads and displays the threads, including if the thread is selected, you have a little pirate emoji next to it, and it's highlighted. Also, you can fetch a list of messages using that get chat thread ID endpoint that we discussed before. The idea here, again, set messages to an empty array, get the messages from the API, and then set messages to the response, and then that's how you end up with what looks like messages here on the right. Messages again, if you have role user, or it's going to show this particular UI with you and a placeholder image. Otherwise, it will show the JS Ahoy bot. So for code formatting, the OpenAI API typically responds with Markdown. So the code is going to be fenced in backtick, backtick, backtick JavaScript, things like that. So the way that I usually display all that is with the marked npm package. That's that one I'm pulling in right here. Just via script tag, I pull in marked, which is a package that converts Markdown to HTML. So that's how. So right over here, this little VHTML note is how you get this nice little gray box that shows code in monospace, where you can actually read the code. So yeah, all this stuff is formatted by marked. Markdown is produced by the OpenAI API. Marked converts the Markdown into HTML, which is rendered right here. A brief aside on a function that's actually really useful for building chat UIs is the scroll to bottom function. Again, when you add a new message, Vue or the HTML isn't going to automatically scroll down to the bottom. It's just going to stay at that particular position, so you might not even see the message as it's coming in. So with this, every time we create a new message or load a new message, we just scroll down to the bottom of the chat thread area. Tricky part, or one of the tricky parts here is the sending a message part. Fetch does support streaming, which is actually very cool. You need to use this little get reader thing on the response body, and then a text decoder. How to put it? It's a little complicated, but this is how you get the streaming to work. So specifically, you have this reader thing, and while the reader is not done, you keep on reading values off of it, decoding the values, and then you have this process event block where you go in and process each individual chunk that came off of that's coming from the server. So processing an event looks, oh, yeah, a second. Yeah, sorry, duplicate slide. So the idea here is with process event block is you're taking in a token that looks something, or you're taking in an event block that looks something like this. So you get data colon and then a JSON string of token colon whatever the token from OpenAI is. So in this case, it's R because hey, we're dealing with pirate code here. So what this code does. Again, you can get multiple blocks in one line, or rather, each block can contain multiple lines. So need to break up by line first, pull out any data lines, parse everything that comes after data, append it to this temporary assisted streaming content. So append to the current streamed content. That's a temporary message that we're going to display at the bottom. And then there's some specific logic for handling when the message is done. Displaying the streaming content, again, this particular little assisted streaming content thing that I'm appending here. That also shows up right here, where I'm displaying the markdown rendered content of assistant streaming content. And that's how you get this nice little partial view of all the tokens that OpenAI has generated so far, along with a nice little pulse animation on this Unicode character that makes it look like there's a cursor that's typing. Animate Pulse is this nice little Tailwind class that just makes something look like it's pulsing, which does a really good job of mimicking like a cursor that's doing something. And finally, handling when streaming is done. What you end up having to do is we clean up we add the actual assistant message to the real messages array. We update the summary, and then we clear out all of the streaming intermediate state. And of course, scroll to the bottom. So yeah, long story short, when people try to tell you that something is just a ChatGPT wrapper, yeah, just the ChatGPT wrapper can be pretty complicated. So this is the relatively easy part, or at least the formulaic part of building a ChatGPT wrapper. The more interesting part, or where things get really useful, is context engineering. So again, this application, like the system prompt, is just hard coded to tell you, like, hey, write JavaScript that sounds like a pirate wrote it. It's funny, it's entertaining, but it's not that useful. From my experience, the secret to getting the most value out of AI is actually getting the right context into the AI. So it's not about picking the right model or tweaking to get the exact right prompt that you want for all cases. It's about inferring kind of what is the right context to feed to the AI, or how do you get the context? Because with how big context windows are right now, it's more about like you don't have to worry so much about picking and choosing the right context. You just have to get all the context that you think is relevant into the context window fast. So system prompt does change everything. Retrieval augmented generation is one way to get the right information into your system prompt, but it's not the only way. So that's all, but yeah, retrieval augmented generation and context engineering is a whole separate talk. I know the streaming part of this talk was a little bit mind warping. So yeah, that's something where you should, where it's easier to just like look at the code and step through it. So a lot of the stuff that I've used, that I demonstrate here in building JS Ahoy, also goes into Mongoose Studio's chat tab. Again, Mongoose Studio is a MongoDB UI that we're working on that has a lot of AI-enabled features, most notably a chat tab that lets you use, demo is worth 1,000 words, right? So these are some of the things that we've done with it, like, just go in here and say, yeah, effectively. So like one of the things what you can do is you can ask it to draw a pie chart of Arnold Schwarzenegger movies by year. You can ask it to do all sorts of things, and it can do a lot of impressive things because it knows your data. Again, the interesting thing about the context that it's able to pull in here is that as a, sorry, give me a second. I got distracted there. But yeah, no, so here's like so Arnold Schwarzenegger movies by a year in a pie chart. So 3 from 2013, 4 from 2014, so on and so forth, right? So when you write an application in Mongoose, you end up defining your data structure in your code. So the way the Mongoose Studio is architected, it's meant to operate within your application. It's meant to be mounted with your application as well. So it ends up being able to pull in your data structures directly from your code. You can also pull in methods and static functions, code that you've written yourself in order to inform in order to inform how to actually, or in order to inform the LLM how to write code or how to answer questions in your particular context. So yeah, different system prompts based on your Mongoose schemas. Question? Sorry, I can't hear you very well. Can you speak up a little? Oh, that is a good question. And again, there's no strict guarantees of that in LLM world. That's part of the reason why instead of immediately executing the code, we actually show you what the code is before it's actually executed. So again, like Mongoose Studio is able to do things like read your data structure, read your methods. So if you have a method that computes, say, what's a particular KPI you might think of? Let's say you have like a static function on users that calculates daily active users, and you have a particular nuance for how you calculate what constitutes an active user. That's encoded in that particular method. We do pass that as context to OpenAI, and OpenAI should be able to pull that out and understand it in theory. But then if it doesn't, well, you're at least able to review the code first. Again, we view this more as like even the system prompt for this particular application tells the application that it's helping you write scripts. It's not answering your questions. It's helping you write scripts that answer your questions, which is a key distinction because LLMs are good at writing code, but they're not good at doing math.
Not that you guys plan to have like MCP agents on this studio, so that I can give you, for example, his formula and say, okay, well, give me the numbers, I'll give you the calculation, and then you do with the calculation what you use.
We're currently not thinking about MCP right now. Maybe someday in the future, but I haven't quite figured out how like MCP would fit into this particular structure right now. Yes. Sorry.
You can also create a schema.
Yeah.
You get close to it.
Yeah, if you have if your KPI is stored as a property in your database, then yeah, the LLM will generate a script that will just get you back that particular property. That would work too. So yeah, again, I have a live demo of Mongoose Studio as well that if you want to check it out with the IMDb data. You do need to sign in with GitHub, but other than that, you can use it. We don't take your email or anything like that, so we won't spam you, and we don't ask for access to any of your private repos. So you don't have to worry about anything like that. Go and generate some charts and play around with the movie data and see what you can figure out. And other than that, that's all I have. Maybe in the future we'll all be like Scotty in Star Trek V and think that keyboards are quaint.
Yeah. What was something that when you were building this chatbot here, or when you're building the studio, you built it as well, right?
Yeah.
What was the unusual thing that you were like, I didn't realize I had to do this chatbot? Was there anything that said to you like, oh my god?
I mean, to be honest, like pretty much everything was new. Everything was new to me because that just came out. Yeah, before I started working on the Mongoose Studio chat, I hadn't really done much with particularly with chat UIs. Like I hadn't built like my own chat UI before. Yeah, no, beyond that, yeah, the complexity of the streaming side really kind of was more complex than I thought, but also more interesting and rewarding than I thought, because I've been needing to do that for Mongoose Studio's database viewer side as well. So like one thing, so Mongoose Studio again is also meant to be a database UI. So like we're trying to kind of marry a business intelligence tool with a database viewer, all kind of wrapped into one. So you have things like when you scroll to the bottom of this screen, we're going to load more. We're going to load more documents, right? But that right now is just done with just a blocking standard HTTP1 request. I'm not streaming things back, which can be really problematic because you can imagine, okay, first it's going to find one document, and then it might have to take 5 minutes to find the next 25 documents that it needs to find. So like I would love for it to just show, okay, documents as they're available, as they're coming in, as opposed to saying the way that the API requests work right now is, when you scroll to the bottom of the screen, get me the next 25 documents in the results set. But it has to wait for all 25 documents to get any one of them back onto the screen. So learning about that has really kind of opened up some new pathways to make the entire project better.
Another question. So you mentioned the stream. Were you doing WebSockets or did you write different thing?
No, it's a different thing. I mean, from what I gather, it's fetch using HTTP2 under the hood in order to stream data partially. Yeah, which is actually very cool because yeah, WebSockets suffer from various limitations and headaches. Yeah, hard to do WebSockets with things like Vercel, and then hard to do them behind load balancers, or at least they used to be the last time I tried to work with WebSockets. So I have always avoided using WebSockets, unfortunately. Yeah. So any other questions, anyone? No? Oh, okay. Well, thank you, everyone. I really appreciate it. And feel free to ask me any questions in person. I'll be here for a little bit.
What are you guys? Are you guys doing work really working with AI work? Okay. And does that mean like as a plugin to your IDE or are you coding AI? Plugin for your IDE or you're actually like the code that you're producing uses AI?
Oh, are you using Cursor or something like that, or Cursor? Yeah. I know every.
What is your favorite? Is it Cursor? Is it Windmill? Windform?
Windsurf.
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 Or is it
Yeah.
the old-fashioned, from me, the grandparents, which is called Copilot, which now has an agent mode, which tries to do the same. My best friend, absolutely. It's been my best friend for like.
What's its name? It said just call me Copilot.
That's what it is.
Nice.
That's good one. That's good one. But they're trying to compete. I mean, they even open source that part of it, so they're trying. They knew that Windsurf and Cursor is just eating their lunch.
Yeah, it is.
It is. It is, but you can choose the models, and one of the models is OpenAI 4.1, which is, I love it. 4.0, they don't say O because there's no benefit of it. Anthropic and Gemini.
Anthropic is Claude, right?
Yes.
Yeah.
It is Claude, please excuse me, I meant to say Claude. And you can choose that on the right side. Same thing as Cursor. With Cursor, am I wrong? Can you choose which LLM there is in Cursor?
Oh, yeah. I think Copilot, GitHub Copilot is great.
Yep.
A better experience than
Really? You got to try. You got to tell us. Right? You're a big Cursor fan, right? All right. Well, let's hear it. What was your experience? Did you play around with the code?
Yeah, I found cursor kept breaking the code.
Oh no.
I found it good to build a prototype and inserting the same letters over and over.
Ooh, okay.
It just might have been my experience. I'm more used to it. The agent mode has been pretty good.
I love it.
That's fair. I haven't. I don't know. Agent mode. I don't know. I haven't been the world's biggest fan, but so far,
You can check it out in the
I mean, well, although recently I've become a